screencast for waves on a string simulation that you'll be doing with your partner as a lab simulation. All right, parts of a wave. In the lab, you're gonna need to define the words that are in the box, and some of those words are crest. So the crest of a wave is basically the top of a wave. So you can see here we have the crest. All of these different points are known as the crest of the wave. All right, there's another crest, and then a third crest. Then we have the word trough, and if you think about a horse trough that holds water, that's going to make sense. This is going to be point is going to be your trough. This point's going to be your trough, and this point's going to be your trough. And so we could label one of those. Trough. And then the line of origin. The line of origin is going to be where the wave starts from, and it will be this baseline that goes through essentially the center of the wave. And so this part right here, we would call our line of origin. Okay. The next thing we're going to look at is our amplitude. And amplitude is a measurement, and you need to know the line of origin to be able to measure the amplitude, because it is the distance from the line of origin up to the crest of a wave. It can also be the line of origin down to the trough of a wave. When you take these measurements on a transverse wave, they would be the same. So you can measure them either way, from line of origin to trough or line of origin to crest. Then our frequency. The frequency is going to be measured in hertz, which is the unit for frequency, and it's how frequent a wave is. Well, before we do that, one of the words that's not defined on there, but you do need to know, is wavelength. And wavelength is a one complete wave. You need to measure from the same part of the wave to the same part of the second wave. So a good example, if you measured crest to crest, this distance from this crest to this crest would be considered the wavelength. And you could also measure from trough to trough, and that would give you the same wavelength. Also, notice how on this part of the wave, it's heading upwards, it's going up. So if you measured from this point of the wave to where it's heading up here, this point of the wave, that would also give you the wavelength. So there's many ways to measure the wavelength. I typically go from crest to crest, just makes it the easiest. Now, with frequency, it's how many of these complete waves you have per a given unit of time. Or in this case, if you were looking at a visual, how many waves you have on this screen. The more that you have, the higher the frequency. So real quick example, if I had a bunch of waves versus just a few, all right, this would have a high frequency, this would have a low frequency. So it's how often you're seeing these waves come back up. If you think back on the electromagnetic spectrum, the gamma rays over on this end had a very high frequency, and the radio waves on the other end have a very low frequency. And then oscillate versus pulse. All right. And I'm not going to write those out, but for your lab, when you oscillate something that's going to repeat over and over, the machine's going to move it up and down and up and down and up and down, and it's going to oscillate or go back and forth. Whereas when you hit the pulse button, it's just going to shoot one pulse for you to measure the wave. So it's just an instant one pulse that propagates throughout. On waves on the string, one of the things that I think you need to know about, I just need to Now, this isn't the exact setup. Well, it's the setup, but not the same amplitude that you'll have in your lab. I do want to talk about measuring. When you click, play with all the different settings, but then set them up like you're supposed to. But rulers, when you put the rulers in, it's important that you make sure when you're measuring things like the amplitude, all right, that you are set right on the 0 mark. Notice the bottom of the ruler is not the 0 mark. The 0 mark is a little bit up. So you'll need to set that right on the wave. Then notice that every one of these marks actually is 2 millimeters. So you have 2, 4, 6, 8, 10, or 1 centimeter, 10 millimeters, 1 centimeter. So when you're making your measurements, be careful. Now, this one, so if you looked at it, we'd be here at 8, and it's about halfway between 8 and 9, 8 and 10. So we'd be at 0.9 centimeters or 9 millimeters. One way to help you do this when you hit the play button is instead of going normal speed, which makes it kind of hard to measure, you can hit the slow motion button. So if you put it on slow motion, hit the pulse button, and then pause it, it allows you to make good measurements. And when it comes to making your measurement on the loose end, once again, make sure that you're on the baseline, and you need to actually move the ruler over to that end to make a good measurement. And just watch the wave as it propagates down. When it reaches its highest point, okay, you're going to hit the pause button. And then that would be 2, 4. In this case, it would be 6 millimeters or 0.6 centimeters. So don't forget to use the slow motion button. The play and pause button is helpful. This is the step button, right? It just steps it along little point by point, which may be helpful as well when you're in the pause button. All right. I think that's all you need. Just follow the directions from there on out.